Hey guys, welcome back to another video. So in today's video, I'm going to be doing a day in the life as if I was oh my gosh. Today I'm going to be doing a day in the life as if I were a medical research assistant. So I don't really know what it's like to be a medical research assistant. I've never been one. So I literally just used ChatGPT for this to try and figure it out. So I asked them to give me a case study to work on, and then I told them what materials I have at home. And then I also asked them to give me a schedule that reflects the typical routine of a medical research assistant. So that's how I got literally all of this. I'm really excited. It's very fun for me, and it's just a way to kind of test what I know and what I can remember based on the classes that I've taken. So I will be telling you in the next clip all about the case study, but that's pretty much all you need to know. This is a super sciencey video, so if you're not interested in that, feel free to click off and watch any other videos. But yeah, so without further ado, enjoy. In today's case study, we follow a 28-year-old male patient named John who has been experiencing shortness of breath, chest discomfort, and occasional dizziness over the last month. His family history includes a father who had a heart attack at 50. John is otherwise healthy, but he has a sedentary lifestyle and a diet high in saturated fats. Given the tools at my disposal, I am tasked with investigating potential underlying causes of John's symptoms by studying the functioning of his cardiovascular system and general cellular health. So my first step, well, actually, I reviewed the case study on John, and now I need to jot down any initial questions or hypotheses about cardiovascular disease, cellular dysfunction, or risk factors. So I'm gonna kind of jot some notes, and then after that, for 30 minutes, I'm supposed to review physiology, anatomy, and public health notes, and then set up my microscope for some microscopic examination of plant and animal cells. So anyway, I'm going to jot down some notes, and then I'll show you guys some of the notes that I have. I also have a whole book on cells, so I'll probably use that too to study. So I'm trying to kind of stick to the time constraints, even though I'm not fully doing it, because it only gives me 30 minutes to review. So I have a ton of notes, and like I mentioned in another clip, I have a whole book on cells, but I kind of want to be smart about it. So I think I'm gonna have to just pick a couple of notes to look at. Since I am going to be looking at cells in a microscope, I think I will. Actually, I might have to use the book. Well, no. Okay, so the book that I have, because I'm going to be looking at animal and plant cells, and the book that I have is for human anatomy. So it's looking at tissues and stuff in humans. So I don't know. I could always look stuff up on the internet, but I'll probably start with this. These are notes from my anatomy class, which I'm not gonna lie, when I think about anatomy, I do feel a little tense. It was a hard class, but I'll probably look at this. And then I think I'm going to very roughly review this because this is a lot. I'm not gonna go through each page, but I'm just gonna try to find little things. And then I wanted to look at kind of a study. This was from my lab in physiology, and it's about cardiac glycosides. So I don't know. I was just like, oh, it's cardiac related, so I'll take a look at it. And then I did want to look at this, the regulation of ventilation and circulation, because my patient, my patient is having shortness of breath. So I figured like kind of reminding myself about how breathing works from a physiological standpoint might be a good idea. So yeah, we'll see how it goes, but I'm gonna study a little bit. And then I'll catch back with you guys when I'm done. Okay, so I just finished reviewing basically all the notes that I showed you guys. This was good for me because I am really bad at skimming. Like, I do not know how to skim through stuff. So it kind of forced me to do that since I had a shorter amount of time. Now I'm supposed to use my microscope to examine prepared slides of plant and animal cells. And it says, while these slides are not directly related to human cells, they provide a foundational understanding of basic cell structure. So I did kind of review basic cell structure for humans. I also have pulled up just a picture of the basic cell structure for plants because I want to be able to know what I'm looking at. And then my microscope is right here. I'll show you guys the slides in a second. Um, and then it says to focus on observing the structure of endothelial cells, which line blood vessels and muscle cells like myocytes. So I'm going to look that up too. And then compare these observations to the cardiovascular system. This actually sounds hard. And then it says to take detailed notes, noting any key differences between plant cells and human like cells, considering how these cells might contribute to cardiovascular health. For example, endothelial cell dysfunction in blood vessels can contribute to atherosclerosis, plaque buildup. So, yeah, let me actually look that up. So, endothelial cells, I'm going to say like maybe in plants and humans. So they regulate blood flow. Oh, there's no equivalent cell type called endothelial cells in plants. Okay. So I'll just look at it. I feel like I should know. Like, I feel like I should have known what that was already. But that's okay. We are learning. So what does this picture show? Let me see. Um, oh, is this whole thing it? Okay, I know it lines blood vessels, but I still am like, what am I looking at? I don't understand. Oh, wait. Oh. Okay. These are the cells that are found in your arteries. I wonder if I have a picture. Well, it's probably not in these notes. It's probably in the notes that I have on blood, which I have them in my backpack, but I didn't think to pull them out. Let me see. Okay, they're in my notes on like the cardiovascular system continued. But if you see like those pictures, it says that it has endothelium tissue, elastic tissue, smooth muscle, and then fibrous, but it's like only a little bit of it. So I don't know exactly what layer it is, but we'll wing it and figure it out. So I'm gonna go ahead and prepare my microscope. I'm gonna wash my hands, even though like I'm not really working with anything, but just to make it as real as possible because I feel like that's what a medical research assistant would do. So I'm gonna do that and then I'll prep everything. Okay, so now I'm going to pick out some slides to use. Maybe, I don't know, maybe 2 or 3 slides. Yeah, so I guess I'll just look at the slides and then take detailed notes, noting any key differences between plant cells and human-like cells. Oh, so I need to choose a plant slide and an animal slide since they want me to note the differences. Where did my pencil go? Okay. No, any differences between plant cells and human-like cells, considering how these cells might contribute to the cardiovascular health. The cardiovascular, um, yeah, the cardiovascular system is one of the hardest for me, so I'm definitely challenging myself right now. I just feel like it's a lot. It's a lot. So I'm slightly overwhelmed right now, but I'm committed to doing this. So we got it. I'm gonna choose, let's see. I'm trying to think what will really kind of mimic this well. I know for the plant cells, I can probably do, let's see. I have quite a few. Oh, this one will probably be the best. So, because I have dandelion fuzz, I have lily pollen, but I think this fiber, the fiber of the plant, it might be a good one to use. So I'll do 4 altogether. The animal ones is what I'm gonna be struggling with the most. Oh, you know what? Maybe for the animal one, this locust wing would kind of mimic it well. I don't know. I'm really truly winging it. Wing. Okay. Anyway, I'll also do this butterfly wing for animal, and then I think I want to stick to leaves. Like I don't want to do fuzz or pollen per se, because I want something that really mimics the structure of like the body of the plant, if that makes sense. And then like the body of the animal. So I am gonna go with, oops, corruption leaf. So I have corruption leaf, fiber, locust wing, and butterfly wing. And I will take a look at these in my microscope and take some notes. So that will be my next move. Okay. I think I'll start with the animals first. They seem easier. And I'll set these over here. No, I'll set them back up here. And then I don't know what I'm doing. I don't know like how I'm gonna take these notes, so let me try to organize it. Microscopic examination of plants and animal cells. And then above that, I'll put case study. Wonderful. Okay. I guess I'll keep this on. But let's go ahead and take a look. Wow, this is very interesting. So right now I'm looking at the butterfly wing, and I looked at it with each like magnification setting. It looks so different when you like really zoom in. I honestly cannot say that I know what I'm looking at, but hopefully by the time I take all of my notes, I'll kind of know. And then I'll put pictures on the screen so that you guys can see a couple of them, and then I'll come back when all of my notes are done. Okay, so that took longer than I thought. I think it was like about an hour and a half, at least an hour, that I was spending looking at the slides, and I did not get to all of them. So I did the butterfly wing, locust wing, and the corruption leaf, which I was gonna do just one animal slide and one plant slide when I saw that I was kind of running out of time, but I accidentally um, looked at the locust wing. I thought it was a leaf at first, so I had to change stuff, but I did take notes, and I don't look at my drawings, but yeah, I did take notes, and I drew pictures of each one. I will be showing you guys pictures on the screen, and I will also read the notes that I have. I'm surprised because I did find connections when I looked at it between the animal cells and the plant cells and the cardiac muscle cells. So pretty cool. For the butterfly wing, this is a picture of it at 60 times magnification. So that's like the highest on my microscope that it could go, which means it zooms in the most. So what I wrote about it is that like they almost remind me of biconcave discs, which are like blood cells, you know? Um, and I don't know if it's bacteria or not. When I looked it up, it said that it could be bacteria, but I'm not sure. And then this is a picture of it at 30 times magnification. So It looks like it's the skin layer of the butterfly. And then at 10 times magnification, which is zoomed out more, you can see like the whole wing and then like the little holes between the different parts of the wings, which is interesting because in like capillaries, there's little pores or something. Like there's fenestrated pores, and what's the other one? I don't remember, but that could like kind of be connected. And then for the locust wing was really, really interesting. So at 10 times magnification, this is what it looks like. You can see, again, like the full wing, and then the walls, right? They look pretty thin, and they're also branched. And that's important because since we're trying to figure out what's going on with John, wait, is that his name? Yeah, since we're trying to figure out what's going on with John with his heart, I know that cardiac muscle cells are branched, and they're interconnected, but they're fat, so they would be thicker. And then at 30 times magnification, which you can see here, the microscope zooms in on the midsection of the wing, and it shows like a thin outline of the rest of the wing. Locusts, they don't have intercalated discs because intercalated discs are found in the cardiac muscle cells, and they're important for coordinated contraction of the heart. But when you zoom in on this, on the midsection of the locust wing, you can see, I'll try to point it out using this picture, but you could see how that midsection, it kind of looks like intercalated disc. So I think that's interesting. And then at 60 times magnification, there's like some thin tissues with some little circles on them. And then like it also looks kind of branched, and I also don't know if that's bacteria or not. Lastly, moving on to the corruption leaf. So the corruption leaf at 10 times magnification has thick branched walls, which is that, you know how there's like your arteries, your veins, all those things. One of those are thick, and I don't know which one. Wait, I think I just saw it in my notes. Hold on. Zoom in, zoom in, zoom in. Okay. Um, anyway, I don't know. The thing I was looking for, I don't know. But at 30 times magnification, it's also thick branch walls with these little like circles next to it that I still don't know what that is. And then at 60 times magnification, it zooms in on the circles. So if you guys like actually know this stuff, please let me know in the comments below. I truly want to know. But I was like, oh, maybe the circles are like chloroplasts since we're talking about leaves here. And I know that plants have both mitochondria and chloroplasts, which help with energy. And that's important because this patient has like shortness of breath. So my thinking is that I think that the mitochondria has something to do with oxygen. Like you need energy to transport the oxygen or something. I don't know. So I'm thinking that it's related in that way, but we'll see. So yeah, that's all that I did. Even though I'm still like, yeah, I don't know what I'm doing, I'm learning more and more as I continue, and we still have lots of stuff to go over. So for right now, I'm supposed to take a short break. I think I might take a nap. I am kind of tired. We'll see. And then after that, I'm supposed to do a heart anatomy study. So I will be looking at the heart model that I have. I'll show you guys all of that in a bit. I have to identify like all the major parts of the heart, and you know, they want me to reflect on plaque buildup so much that I'm like, is that just the answer? You know, and I'm like doing all this stuff, but they gave me the answer. I don't know. But anyway, I have to reflect on that, and then I have to write down observations on how all of this would explain John's shortness of breath and his chest discomfort. So that will be what I do next, but for now, I'm going to take a short break. Bye. Okay, so what did I just do? Oh, I wanted to show you guys a student in my physiology class. She made these, like had them laminated and passed them out. to the whole class to help us when we were studying. So this has actually come in handy for what I'm doing today. And then I also used this. These are my anatomy notes. I'm glad I didn't throw them away, even though I was kind of thinking about throwing some of my anatomy notes away. This really came in handy. So anyway, this is my little heart model. I put a bunch of sticky notes on it because really the heart is difficult for me. So I am going to go over like each part. I'm not going to keep those sticky notes on just to kind of get familiar with it again. And then I literally wrote down like the function of all of these things because it's easy for me to forget. And then I feel like I'm going to need these notes too, that just show you like the flow of blood through the heart. So I'm going to keep these things close by. I'm going to go over this real quick, review my notes, and then I'm supposed to get a lunch break. So I'll do that. And it said, well, actually, okay, I'm supposed to reflect on atherosclerosis or plaque buildup and how it could impact the coronary arteries and obstruct blood flow to the heart muscle, leading to conditions like an angina or a heart attack. Write down observations on how impaired blood flow in coronary arteries could explain John's shortness of breath and chest discomfort. So what I will say is like I took like basically introductory anatomy and physiology. So we learned about some pathology, but not a lot. So I will watch videos on this, and then it does tell me to take an hour lunch break. It says this could be a good time to review research articles or look into case studies involving young adults in cardiovascular disease. Consider how dietary habits, saturated fat intake, and a sedentary lifestyle could be contributing to John's symptoms. I'm sorry, but I like would not want to be studying on a lunch break. But I will try. I'll probably watch videos on all the things I talked about while I'm eating. But I don't know if I would spend my whole lunch break doing that. That probably is what like medical research assistants do, or like I would definitely think that doctors would probably do stuff like that. But no, if I'm taking a break, I want like a real break. Anyway, that's just me. But let's go over this heart. So this is I'm just gonna say what these things are. I'm not gonna I'm not going to say the function for all of them because I can't remember off the top of my head. Can you guys see that? Maybe I'll put it a different way. I just want you guys to be able to have a better picture of it. So, gosh, these are actually kind of in the way. I think I know all of these. So this, wait, let me see if I can take this out. There we go, that's better. Okay, here's the heart. It's magnetic, so it would close like this normally, but I'm dropping everything. No, which one did I just drop? Oh, left atria. I know where that is. Okay, so this is the superior vena cava. This section here is the right atria. Yeah, it's the right atria. This is the, wait, hold on. I always think of lab rat, so left atrium bicuspid valve, right atrium tricuspid valve. So this is the tricuspid valve right here, this white part. And then going, I guess, onto this side, oh, right here, this blue section right here is the pulmonary artery, or also called pulmonary trunk. This is, technically this part right here, I guess, is the aortic arch, but this whole thing, this whole red part is the aorta. And then this part right here, oops, I'm dropping stuff. This part right here, this whole area is the left atrium. This white part right here is the bicuspid valve, and then this whole part in here is the left ventricle. So I kind of know those, but some of the other ones are harder. And then back here, this red part, I don't know if it's both of them or just this one. It's the, I took it off and I just lost it. It is the, okay, there we go. It is the, right here, the pulmonary vein. Okay, and then I'll put that back on here. And I still have pictures and everything, so if I forget, it's fine. But right here, these ones I am going to be careful with. Right here is the um, right coronary artery. And then right here is the left coronary artery. So, yeah, there's that. And so, like I said, now I'm just going to study some of those definitions. I will eat. I think, I do kind of think it's weird to like eat and watch videos about like heart attacks and stuff. I don't know. I just like, it makes me feel weird. But anyway, I'm gonna eat and then while I'm eating, I'm gonna watch a video about plaque buildup, heart attacks, and maybe start looking at some public health stuff. So we'll see. We'll see. I don't know about that one, but I'll definitely look at the plaque buildup and the like stuff related to heart attacks. So, okay. See you then. Thank you guys so much for watching. I will be ending the video here, but I will be doing a part 2 to finish up the case study. Let me know what kind of videos you guys would like to see, but I had so much fun doing this, and I will talk to you guys in my next video. Bye!